Here we're asked to evaluate the limit of these two functions here. So the first thing that I do anytime I'm trying to evaluate a limit is plug in the value that I'm approaching, right? So I'm going to plug in 3 for this one here. I get 2 times 9 minus 9 times 3 plus 9 over 3 squared, which is 9, minus 5 times 3 plus 6, 18 minus 27 plus 9 minus 15 plus 6. And what I end up getting here is 0 over 0. This is called indeterminate form, or if I get 0 over 0, basically what I like to think of is that, like, I know I need to do more work because this doesn't say anything about a limit. When I have 0 over 0, that could mean that I have a hole, but that doesn't necessarily prove to me that the limit doesn't exist, because the limit doesn't care about the point. They just say, like, hey, does the left side approach the same value as the right side? And if that's true, then the limit exists. So in this case here, because I get this 0 over 0, it tells me I just need to try something else. This video specifically is talking about when we have to factor the top and the bottom. So when we factor these two things here on the top and the bottom, hopefully we'll see that we can cancel something out, and then we'll try plugging that x equals 3 in one more time. So I'm going to take a second to speed this up and get all the factoring done here, and then we'll move on. All right, so once I've factored this, I see that my x minus 3 over x minus 3 cancel, and so I'm left with just 2x minus 3 over x minus 2. Now, when I try plugging 3 in again, I get 2 times 3, which is 6, minus 3 is 3, 3 minus 2, which is 1, and so I get a number, and that is what the value of my limit is. Second one here, same idea. If I were to plug in negative 2/3, I'm going to fast track this a little bit. If I plug in negative 2/3, I'm going to tell you that it's, not negative 2/3, negative 3/2. I think this problem was actually supposed to be. That's my fault. If you plug in negative 3/2, that should give you an issue there. So we're going to go ahead and factor here first, and we'll see what ends up popping out. So I'm going to factor these real quick, and then we will see what we can do. So once we factor this here, we should see that the 2x plus 3's cancel. And now I'm going to plug in negative 3/2. So negative 3/2 minus 1 over 3 times negative 3/2 plus 4. So this becomes negative 5/2. Nope. Yeah, negative 5/2. And this becomes, what is that? 3 times 3 is negative 9 over 2. And that's going to be, what is that, 8? So just negative 1/2. Is that right? Yeah. And then when I divide two fractions here, it's negative 5/2 times negative 2 over 1, which just gives me my value of positive 5. So this original limit here, all the way back in this here, is equal to 5.